All right, this lesson is from 2.05. We're looking at multiple representations of linear equations here. And so hopefully by the end of this, you're going to know how to think of a linear equation in terms of a real life situation like the one we have here, an equation, a table, and a graph, and see how they all connect. So you are going to rent a car. There's a $50 insurance fee for every rental, and each day the rental fee is $80. So it's important to notice that in this situation, that $50 insurance fee is just a one-time fee. It's not per day, but the each day rental fee is $80. So if we're thinking about an equation, in the form y equals mx plus b, the constant, the b, the intercept, that's the base value for renting it. So no matter what you rent for how many days, that's the fixed fee. So the fixed fee, that's going to be our $50. And then the each day, so x here, x will equal the number of days, and m will be the cost per day. So remember, this is our slope, and this is our y-intercept. Okay, so we'll think about this situation in those terms. So the equation will be y is equal to, each day it's $80 times the number of days plus $50 for that insurance fee. So 80, that's our slope, and a positive 50, that's our y-intercept. So if we think about a table that's going to be representing this situation. Whoa, that's not what I wanted to do there. Sorry about that. X, remember that's the number of days for the rental. And Y will be the total dollars for that many days rental. Okay, so again, the number of days for the rental. And, I could do something like highlight this Y, but we can just leave it, I think, like that. Oops. Actually, that shouldn't be green here because it's the $80 per day that is the slope. It's not the number of days. So if we have 0 days, this sort of doesn't make sense. It's saying, hey, even if you rent it for 0 days, you're going to have to pay $50. That's the y-intercept. But that's the way that these kinds of problems work out, is that the any fees associated with it will be the amount for day 0. On top of that, after 1 day, you can think of it like this. I have to pay the $50 for the insurance, and then after 1 day, 80 times 1, that's 80, plus 50 is 130. So I'm going to have 130 here. And similarly, if we have 2 days, 80 times 2 is 160, plus 50, that's 210. So after 2 days, it's going to cost me $210. If we continue on like that, 3 times 80 is 240, plus 50 is 290. And what I hope that you see is that as our x value is increasing by 1, in each of these, our y value is increasing by 80. And that is our slope. Because our slope is 80 over 1. So the slope here can be seen as 80 over 1, which is equal to 80. All right. So you can see our slope there. And you can see our y-intercept there. When x is 0, the y value is our x-intercept. And so when we think about that, what we have is a situation, if we're going to graph it, on our x-axis, this is the number of days. And our y-axis, that's going to be the total dollars spent. All right. And so we know that we're going to be, as our days increase, the dollar amount will increase. So it's going to be going up like this somewhere. And we also know that the y-intercept is going to have to be 50. So on the y-axis here, it's going to have to be 50. So we have to decide where we're going to put that. And then each time we increase our x value by 1, we go up 80. So we're going to have to really spread out our x-axis here. So 1, 2, 3, 4, this is 5 days. This is, so this is 1 day right here. So for every 2 grid marks, we're going to have, let me scoot this up just a little. It's going to be every 2 grid marks is going to be 1 day. And on the x-axis, we have to increase by 80. On day 3, so day 3 here, we're going to have to be at $290. So I think that let's do, each one of these is going to be 50. So that'll be 500 right there. All right. 10, 20, 30, let's see, so 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. All right. So on day 0, we spend $50 right there. So that's going to be 0, 50. And I'm going to highlight that with that kind of a fuchsia pink color. And then on day 1, it's 130. So let's see, this is 100, that's 150. So 130 is going to be about right there. On day 2, it's going to be 210. On day 3, it's going to be 290. And so what we can do is we can just take that line and we can extend it out like that. It's not perfect. It's pretty close. There we go. So that is, we can add some points here. 1, 130, 2, 210, 3, 290, and so on. So there we have, oh, I can also add in, maybe would be a good idea, a slope triangle so that we can see the slope here between 2 points. So I'm going to go between these 2 points right here. And here, the change in x from this point to that point, 2 to 3, the delta x equals 1. And the change in y between those 2 points, the delta y equals 80. So we can see that the slope is represented by that situation, 80 divided by 1. And so in each of our situation, we can see the y-intercept. In the equation, we can see the y-intercept. In the table, we can see the y-intercept. And in the graph, we can see the y-intercept. In the situation, we can see the slope. In the equation, we can see the slope. In the table, we can see the slope. And in the graph, we can see the slope. So in each representation, you can see all of the important parts of the relationship. I hope that's helpful. Thank you very much.